Welcome back to my YouTube channel. In the previous video, we designed a modern product searching interface using HTML and Tailwind CSS. But the search interface alone is not useful unless we connect it with the backend system that can actually retrieve data from the database. So in this video, we are going to implement the backend logic for the product searching system using PHP and MySQL. Inside this tutorial, we will cover how the search keyword is captured, how product filtered from the database, how product data is retrieved using SQL joins, how rating and customer count are calculated, and most importantly, how pagination works to handle large amount of data efficiently. This is a very important concept used in real-world web applications, especially in e-commerce websites and host marketplaces. So without wasting time, jump into the code. Start in the session. At the top of the file, we start with PHP session. Sessions are used to store user data such as login status, user ID, and account type. Here we first check with the session already exists. If not, we start the session using the session start function. This ensures that session variable can be accessed safely throughout the page. Database connection. Next, we include the database connection file. Require once dbconnection.php. This file cannot connect our application with the MySQL database. In this project, we use a helper class called database, which provides a method called search. This method allows us to execute prepared SQL queries safely. Authentication check. Next, we check whether the user is logged in. If the user is not logged in, the system loads the authentication check-in script. This script usually verifies login sessions, remember me cookies, and user access permissions. This ensures that only authenticated users can access the search page, getting user session data. After that, we store session value inside variables $logged in, $user role, and $user ID. These variables help us manage the user information easily. For example, $logged in tells whether the user is logged in. $user role stores the user account type. $user ID stores the unique user ID. These values can be used later for personalization of permissions control. Capturing the search keyword. Now we move the core part of searching process. First, we retrieve the search keyword from the URL. The search input field sends data using the get method. Example URL search product.php section q equal design. Here the q parameter contains the search keyword. The trim function removes unnecessary spaces from the begin and end of the text. If the user does not type anything, the variable will simply contain the empty string. Pagination variable. Next, we define variables required from pagination. Pagination is necessary when we have large numbers of products. Instead of loading 100 of products at once, we divide them into pages. Here we read the current page number from the URL. Then we convert it into integer using int12 and ensure it is never less than 1 using the max function. Then we define how many items will be displayed per page. In this case, we show 12 products per page. Build in the where clause. Next we start building the SQL condition $where clause equal where p.status equal active. This ensures that only active products appear in the search results. Then we check if the search keyword exists. If it exists, we add an additional filter. p.title like question or p.description like. The like operator allows us perform partial text searches. Example: searching for design may match UI design, web design and graphic design code. The percentage symbol acts as validates that allows flexible matching. Prepared statement. Next we define parameters for the queries. Prepared statements help protect the database from SQL injection attack. Instead of inserting user input difficulty into SQL queries, we pass them as parameters. This ensures that malicious input cannot break the query. Security like this is extremely important in production application. Count in total result. Before fetching products, we must know how many results exist. This is request for pagination, so we execute a counting query. Select count p.id as total. This query count how many products watch the search conditions. Then we calculate the total number of pages. $sign total product pages say $sign total count $sign items per page. The sale function round numbers upward. For example, 25 products with 28 items per page will require 3 pages. Calculating offset. Next we calculate the offset. $sign offset equal $sign current page minus 1 multiply $sign items per page. Offset determines where the database should start retrieving records. Example: page 1 start from 0, page 2 start from 12, page 3 start from 24. This ensures that each page displays a different set of products. Product retrieval query. Now we write a main SQL query. This query retrieves data from multiple tables. Tables use product, user, order and feedback. Using left join, we combine product data with related information. For example, seller name comes from the seller table, customer count comes from the order table, and rating and review count come from the feedback table. This allows us to show complete product information in the search result. Aggregation functions. Inside the query, we also use aggregation functions such as count avg. For example, count distinct o.id. This calculates how many customers purchase the product, and avg f.rating. This calculates the average product rating. These statistics help users evaluate the quality of the product. Limit and offset. At the end of the query, we add pagination controls, limit, offset. Limit specifies how many records should be retrieved. Offset specifies where the result should start. Together, these two commands allows us to read only a small portion of data at a time. This greatly improves website performance, sorting and product result. After executing the query, we loop through the result set. This convert database rows into a PHP array. Later, this array is used to generate the product card into the front end. Pagination navigation. Finally, we create a pagination navigation. Then pagination system include link for first page, previous page, page number, next page and last page. Each link updates the URL like this: question page equal to and queues equal design. Notice that we keep the search keyword in the URLs so the search filter remain active while switching pages. This ensures a smooth user experience. Handling empty result. If no products watch the search query, we display any empty state. Instead of showing nothing, the interface displays an icon, a message, and helpful buttons like browse all or clear search. This improves visibility and helps users count, exploring and platform. Conclusions. So that is how you can program a complete product searching process with pagination using PHP and SQL. In this tutorial we covered session handling, computing search input, dynamic SQL, query building, prepared statement for security, counting total results, pagination logic, and retrieving product data from multiple tables. Alright, these techniques are widely used in real-world systems like e-commerce websites, post marketplaces, digital product stores, and content management systems. If you found this helpful, don't forget to like, subscribe, and hit the bell for more web development tutorials from DV Codex. See you in the next video.